Okay, 8.5 is the last section in Chapter 8. We're going to talk about systems of equations in this section. A system of equations consists of two or more equations, and I've got some examples of some systems shown below here. So here's one example. I've got two equations, and the unknowns are x and y. Okay, typically we use like a bracket to enclose the equations. You'll see that in a lot of books. The idea is to find the values of x and y that would satisfy each equation here in the system. Okay, now we're going to learn some methods to do that, but here'd be another example. Okay, I've got two equations with two unknowns, and the unknowns are x and y again. Okay, now we call this a nonlinear system. In other words, with that y squared term there, we don't have lines. Okay, now we're not going to have to deal with systems like this in this course, but there are nonlinear systems, and you would learn about that later in Math 115. The idea would still be the same, solve the system, or meaning that we'd want to find x and y such that both equations would be satisfied. So, like I said, our focus is going to be on linear equations. So we're not going to have to worry about like a y squared or a square root of x or something like that, or a 1 over x or something. Those are not lines. Here's another example. In this one, I've got three equations with three unknowns. The unknowns are x, y, and z. Okay. Our focus is going to be just on two equations with two unknowns, although they do have some bigger systems in the section. You can look at that. We're just going to stick to 2 by 2 here. Is going to be good enough. Okay, and here's another example. Now the number of unknowns doesn't have to match the number of equations. Like here I've got two equations and there's three unknowns. And I'd still want to find x, y, and z such that both equations here would be satisfied. Okay, now a solution to the system is an ordered pair x, y that would be a solution to each equation in the system. If we take a look at problem 22, okay, I've got this system here rewritten. Determine if the ordered pair 1, 3 is a solution to the system. So are the equations going to be satisfied when x is 1 and y is 3? Well, let's plug it in and check it out. So in the first equation, 2 times 1 is 2, plus 3 is 5. That looks good. And in the second one, if x is 1 and y is 3, I've got negative 1 plus 3 times 3. Negative 1 plus 9 is 8, not negative 6. So 1, 3 would not be a solution to the system. In other words, it didn't satisfy all two of these equations here. If we take a look at problem 23, okay, determine if the ordered pair 3, negative 1 is a solution to the system. Well, same deal, plug it in and see if the equations are satisfied. So in the first one, if x is 3 and y is negative 1, 2 times 3 is 6, minus 1 is 5, that's true, okay? And on the other one, negative 3 plus 3 times negative 1, negative 3 minus 3 is negative 6, that's true. Okay, so x equal 3, y equal negative 1 would be the solution to that system. Okay, now, if we go to the next page here, some terms. A system that has a single solution is called an independent system. Okay, a system that has no solutions is called an inconsistent system. We'll see that. And then a system that has infinitely many solutions is called a dependent system. We'll see that also. In this section, we're going to focus on three methods for solving a system of linear equations. The methods that we'll use here are the graphing method, the substitution method, and then the addition method. Okay, I'm going to start with the graphing method. So here's an example, problem 24. Use the graphing method to solve this system. In the graphing method, you're going to graph the lines that are given to you, and your answer will be the point where the lines intersect each other. Okay, so I've rewritten both of these equations so that they're in the form y equal mx plus b. The reason why I did that is so that I could graph each one of these lines using the slope and the y-intercept. So in the first line, y equal x minus 5, this has a slope of 1 and a y-intercept at negative 5. Okay, so I can start here at 0, negative 5, and then work off of the slope. The slope is 1, so I'm going up 1 into the right one, up 1 to the right one, up 1 to the right one. Continue that, okay, and you're going to draw that line passing through those points then. Okay, now the second line, y equal negative 2x plus 1, that has a slope of negative 2 and a y-intercept at 1. So, okay, here's 0, 1, where that line crosses the y-axis. I'll use that as a start point and then work off of the slope. The slope is negative 2, so I'm going to go up 2 and to the left 1, since that's a negative, up 2 to the left 1, or you can go down 2 into the right 1. You know, do that a couple of times. You'll generate some points flowing in the other direction there. And then after you got some points, go ahead and draw on that second line. Okay, now my answer is where the lines intersect each other, which means that when you're using the graphing method, like any other graph, you'd want to be neat with what you're doing. You don't want to quick slop up something and then have to eye down where the lines intersect each other. If you're doing it like that, if you're trying to be quick with it, it kind of defeats the purpose of using this method. Okay, so try to be neat with it, you know, like any other graph. So it looks like these lines intersect at the point 2, negative 3. So I think that x is 2 and y is negative 3 would be the solution to the system. Okay, now I can check my answer by plugging the numbers in and making sure that these equations are satisfied. Let me do that now. X is 2, y is negative 3. So is it true that 2 minus negative 3 is 5? Yeah, 2 plus 3 is 5, that's true. And is it also true that 2 times 2 is 4, okay, minus 3 is 1? Yeah, that would also be true, okay. So x equal 2, y equal negative 3 would be the solution to that system. Pay attention to how the answers should be written in using MyMathLab, okay. In some programs, they want the answer to be written as an ordered pair, you know, as a point. And then in others, you just simply type in, you know, whatever number x is and whatever number y is. And so here's another example, okay, problem 25. Again, we want to use the graphing method to solve this system. Okay, now the second equation has already been solved for y, so in the first equation, I've got that rewritten over here, and I'm going to solve that for y. I've done that, okay, and excuse me, it's right here. And so I'm going to graph both of these lines. Okay, now it's still the same system, right? I've just rewritten the first equation. So I'm still working with the same two equations, though. So the first line, this guy here, has a slope of negative 4/5 and a y-intercept at 2. So I can start by plotting the point 0, 2, where that line crosses the y-axis, and then work off of the slope. The slope is negative 4/5, which means that I want to go up 4 into the left 5. That's going to bring me to that point there, okay, or I can go down 4 into the right 5. Same thing. And I can generate some points, flowing in the other direction. So using those 3 points, go ahead and draw on that first line there. And then now the second equation, y equal negative 3/5 x plus 3, that has a slope of negative 3/5 and a y-intercept at 3. So I'm going to start here at 0, 3 on the y-axis and then work off the slope. The slope is negative 3/5, which means I'm going to go up 3 into the left 5. Okay, or you can go down 3 into the right 5. Gather up a couple of points on this line. Here I've got 3 points to work with, and I can then draw on that second line. Okay, now my answer is going to be where the lines intersect, and we can see from our picture here that those lines intersect at the point negative 5, 6. So I think that x is negative 5 and y is 6 would be the solution. Let me check that. So if I plug in the numbers here in the first equation, is it true that negative 20 plus 30 is 10? Yeah, that's true. And is it also true that, negative 3/5 times negative 5, that'd be the negative 5s would cancel. 3 plus 3 is 6. Y is 6. Okay, so that would also be true. Yeah, x equal -5 and y equals 6 would be the answer then. Okay, here's another one. Problem 26. We're using the graphing method again. So again, I've rewritten these two equations in the form y equal mx plus b. With the first one, I'm going to subtract 2x. Okay, and so I've got that here. With the second one, if you subtract 4x and then divide by 2, I've got y equal -2x plus 4. Okay, so here's my two lines that I've got to graph. Y equal -2x minus 1 is the first one. That has a y-intercept at -1, and the slope is -2, so I'll need to go up 2 and to the left 1, up 2 and to the left 1, up 2 and to the left 1, or you can go down 2 and to the right 1, same thing. And using those points, go ahead and draw on that first line. And then the second line, y equal -2x plus 4, that has a y-intercept at 4. So, okay, here's 0, 4 on the graph, and the slope is -2. So I'm going to go up 2 and to the left 1, or, go down 2 and to the right 1. I do that a couple of times, gather up some points here, and then draw on that second line. Okay, so I've got these two lines here, and my answer is where the lines intersect. Now these lines are parallel lines. Parallel lines will never intersect each other. How I know that they're parallel is because parallel lines have the same slope. Because these lines will never intersect each other, there's going to be no solutions to this system. A system that has no solutions to it is called inconsistent. I mentioned that earlier on the previous page there. An inconsistent system is one that has no solutions to it. Okay, and the empty set sign is a symbolic way that you can say no solutions. Okay, here's problem 27 is another one. Use the graphing method. Okay, if I rewrite these two equations here, on the first one, add 2x to both sides, you get y equal 2x plus 4. And then on the second one, if you divide by 2, you're going to have y equals 2x plus 4. Okay, so let me graph both of these lines here. The first one, y equal 2x plus 4, that has a slope of 2 and a y-intercept at 4. So here's 0, 4. I can use that as a start point and then work off of the slope. The slope is 2, and so I'll need to go up 2 and to the right 1. Okay, or I can go down 2 and to the left 1 a couple of times and gather up some points there and draw that first line. The second line then, y equal 2x plus 4, I would draw that again. Okay, so what I'm looking at is a line on top of a line, okay, since I've drawn the same line twice. Now my answer is where the lines intersect each other. Well, if I've just drawn the same line twice, there's going to be infinitely many times that these lines will intersect each other. So I'm going to have infinitely many solutions to this system. Okay, a system that has infinitely many solutions to it is called a dependent system. That was from what was mentioned earlier there. And now as far as my answer goes, I'm going to have to write my answer as an ordered pair, x, y, but I want everything about that to be either in terms of x or in terms of y. Now I already know what y is in terms of x, right? Y is 2x plus 4, so in the y coordinate spot, I'm just going to simply write 2x plus 4. And I'd circle this answer. Now what I'm saying here, this is basically one way to describe to somebody that there's infinitely many solutions to this system. You can give me any number for x that you want, okay? Whatever number you tell me, I can always find a y value by taking 2 times that number and then adding 4. So I'll be able to generate infinitely many points on these lines, therefore creating infinitely many solutions to the system. Okay, that'd be a dependent system. Okay, now there's a note, which is kind of important here below that problem. It says solving a system of linear equations does have a major drawback. Sometimes we will not be able to accurately determine the coordinates of the solution of an independent system. For example, if we have this system of equations here, if we were to solve this, I'm not going to do that, but if I were to solve, the solution would actually be x equal 35/8 and y equal 11/4. Okay, now in making a graph, do you think that if I were to draw these two lines, it would be easy for somebody to see the point where those two lines intersect each other, which would be this point here, 35/8, 11/4? I think that would be kind of a difficult point to see on a graph, okay? Because many graphs are set up to use an increment of 1, and you get like nice counting number of values, in this particular method. All right, so this particular method is really not ideal if you're going to sketch a graph by hand, and the numbers are just kind of like these oddball numbers here. Okay, therefore, it's necessary to know some other algebraic methods rather than just the graphing method. The two other methods that we're going to look at in this section are called the substitution method and then the addition method. Okay, and I'll talk about those in the next video.